Okay. Third order matrix. Other than the third order matrix, you could find a determinant by using your calculator. Okay, there is a determinant button if you were goofing around at all in the matrix section. There is a math part of the matrix section. Okay, if you pick up your calculator, go to your matrix button, see where it says math, use your arrow key to go over to where it says math. What's the first one down say? Determinant. Okay, so like if I wanted to find the determinant of matrix A, if it was a square matrix, I would just hit that button, then I would select matrix A, and it would give me the determinant. Okay, does that make sense? Now, if it's not a square matrix, you can't get the determinant. All right, two ways to find the determinant of a third order matrix. Hold on. Let's just put a matrix up here. We're going to do small numbers so we don't have to stress our brain. Okay, third order, which means it's a square matrix, which means I can do it. There's two different ways to do this. The first way is not my favorite way, but I'm going to teach you that way first. Okay, this year, you will have to be able to do it both ways. Now, when you move to, I think it's my pre-cal book, that only teaches it this way. It doesn't teach it the other way that I'm going to show you how to do it. But this year, you've got to know how to do it both ways. This is called expansion of minors. Now, I don't know why, but for some reason this makes me think of a baseball team. I don't know, minor leagues or whatever. It has nothing to do with that. But there is a pattern by which you do this. You pick the number that's in the first row, first column, and you multiply it by its expansion of minors. And you go, what is an expansion of minors? Well, basically, you are eliminating out all the numbers that are in its row and its column. So I'm finding the determinant of what's left. Okay? Reagan's going, no, not okay. Okay, basically I just mark out everything in the row and column of that number. So what I have left are these four numbers right here. Okay? Then I go on to the next part. I'm subtracting because this is what my pattern says. And I pick the number that is in my first row, second column. So I pick the 4. Then I multiply it by the expansion of its minors. Now that means all the numbers that are with a 4, column-wise and row-wise, are eliminated out. So its determinant that I'm doing is -1, 6, 3, and -3. With me so far? Okay, then my formula says plus, and I pick the number that's in the third spot in the first row in the third column. So -5 times the expansion of its minors. Well, now I've eliminated out, obviously I eliminate out the first row every time, but the third column. So I have -1, 0, 6, and 7. Okay? Does that make sense, what I put up there? Okay, kind of weird, but again, we go back, who in the world came up with this? Okay, somebody that is smarter than me. That's who came up with it. So now I've got to find the determinant of all these. I know how to find the determinant of a second order matrix. So I go 0 times -3 is 0 minus 21, right? I'll get to the answer for that in a minute. So 3 minus 18 and -7 minus 0. Okay, for each one of those. Then I have 2 times -21, which is a -42, right? I'm going to go ahead and add the opposite of my second number there. So I have a -4 times a -15. That's going to give me a negative, actually a positive, 60. I believe that's right. Okay, because I have negative 4 times negative 15, which is positive 60, plus negative 5 times negative 7, which is a positive 35. Okay? Then I just have to add these. So I have 95 minus 42, which is 53, and it would be positive. That's my determinant. Weird, huh? Okay, let's do another one of these. Like I said, I think you're going to like the other way better, but that's just because I like the other way better. So I'm a little partial to that, but we're going to do another one like this so that you can get the pattern over and over. The only reason why I like the other way better is I always get mixed up that I got to do the minus before I do the plus, okay? So let's do another one. You'll find that you like the zeros in these because it makes life much easier. Okay, let's put a 0 up there so I can show you. Okay, and again, if they just have parallel lines, you know you're trying to find the determinant of it. Okay, so what's the first number I pull?
5.
5 times the determinant of what?
Negative 3, 1, 2, 4.
Negative 3, 1, 2, and 4. Because remember, cross out the row and the column the 5's in. Then what?
4.
Okay, but minus, minus 4. And what's the determinant I'm doing there?
Negative 7, 1, 2, 4.
Negative 7, 1, 2, and 4. And then
Plus 0.
plus 0. Oh, you know what? It doesn't really matter what's back here. That's what's so nice about having a 0 at the top. Now I can write it out and I go negative 3, or negative 7, negative 3, 2, and 2. But 0 times anything is what?
0.
0. So I don't have to do anything back there. Okay, I can just for the practice of it, but there's no sense in doing it. All right, so I'm over here. Remember, I multiply up, so I have a negative 12 minus 2. So that's going to give me a negative 14, right? If I want to, I can go ahead and do that. I'm going to get a negative 70. I believe that's right when I multiply. Okay, somebody check my math there. Negative 14 times 5. Check it real quick. Okay. I'm going to add the opposite here. Negative 28. I always add the opposite because I just think it's easier for me to remember that that's a negative number and multiply it there. So negative 28 minus 2. So I have a negative 30 times a negative 4. That's a positive 120. Okay? Then I don't have to do anything over there. So now I've got, I'm going to have an answer of 50. Okay? Make sense? All right. Now I'm going to show you the other way to do it. Okay? That's by expansion of minors. I think you'll like the other way better. But like I said, that's just my opinion. Okay. What you do, the other way is called by diagonals. Okay? You know what a diagonal is. Okay? So I have to recopy the first two columns again. 5, negative 7, 2, 4, negative 3, and 2. And this is by diagonals. Okay? Now, I'm going to multiply up, multiply up, multiply up. Okay? And then I will multiply down, and multiply down. Okay, so I have got a negative 12 times 5, which is a negative 60. And I have an 8, and I'm adding in between these, and I have a 0. So on the top, I have a negative 52. Okay, are you with me so far? All I did was multiply the diagonals. Okay, check my math, make sure my math is right. On the bottom, I have a 0 plus a 10 plus, I'm not sure what that is. I'll do that in my head real quick. 28, negative 28 times 16, or times 4. Negative 112. Okay, so if I add the bottom, I'm going to have a negative 102, right? Would you agree with that? You with me so far? Okay, now all I have to do is take the negative 52 minus the negative 102. In other words, I add to get those, and then I subtract the negative 52 minus the 102. So I have a positive 102 because I have a double negative. So guess what my answer is? Oh, it seems like I've seen that somewhere before. Okay, I think this way's easier, but that's just my personal opinion. Okay, I do have students that sometimes, because I teach them expansion of minors first, they like that way better. Okay, let's do another one that's diagonals. You ready to try one that's diagonals? Yeah, maybe? Okay, let's go. I'm gonna have you try this one. I won't do big numbers. Okay, by diagonals. Solve that, find the determinant by diagonals. And while you're working at it there, once you get it copied down, I'm going to work at it up here.
So it's add, minus, did you say?
It's you
Add.
multiply,
Uh-huh.
then you add, then you subtract.
Uh-huh.
Okay? No, and mine might not be right, so don't go. Let me see.
So you track the two numbers, the top and bottom number from each other?
But always go top minus bottom. Always do it in that order.
So what do you
Okay,
do first?
okay, I recopy the first two. Got that much?
Mhm.
Okay, then I multiply the diagonals up. Okay, now it's real important to have it neat so that you know what are in what diagonal. Okay, so 2, -2, and 2 is -8.
So you have to multiply in the middle. You don't just multiply the top and bottom of
No,
the
no, no, no. You multiply the diagonals. I multiplied this one and got -140.
Okay.
Multiplied this one and got 0. Then I add those.
Okay.
Okay, and I just write the number over there. Okay, then I'm pulling down. Okay, and I multiply this set of diagonals. So that's going to be a -30. That one's going to be 0. This one's going to be a -24. Then I add those, which is going to give me a -54. Then I take this minus this.
Okay.
Okay,
Okay.
that I mean it can get very confusing. Okay, so when you go to do your homework, the more you do like this, the easier it'll be. Okay. Yes, no, Callie, you got it. Joseph, you got it. More or less, you hope. Okay.
Mhm.
All right. Okay, there's one other thing in this section, and this is kind of a cool thing with matrices too. Okay. Matrices actually, and I guess geometrically, it's where they have the most application. Let's say I have got on a coordinate plane, I have this triangle. And I have 5, 4. And I have 3, negative 4. Call that A, B. And I have negative 3, 2. And I go, all right, give me the area of this triangle. How do you find the area of a triangle? Y'all remember? You know the formula. I'm pretty sure you do. Area is equal to 1/2 the base times the height.
Yeah.
Okay, you've seen that before. I know you have. And you go, well, to find the height of it, I'd have to drop a perpendicular line straight down here. I've got to figure out the equation of this line, figure out the point that it intersects with. Then I'd have to use the distance formula. I'm like, this is way too hard. If I could make this easier, I'm going to make it easier. Well, guess what? There's definitely an easier way to do it. Okay, what I'm going to do, the formula says, if I turn around and I write these x, y, x, y, x, y, and I put 1s right there to make it a square matrix. Okay, so I'm putting the x and the y, the x and the y, the x and the y. I find the determinant of that and I multiply it by 1/2, it's going to give me the area of that triangle. How cool is that? Okay, so I can do this by expansion of minors. I can do it by my calculator. I can stick that matrix into my calculator, find the determinant of it, and work my way through. Actually, let's see. You find that if we did it all out, okay, and you could do expansion of minors or you could do diagonals, this is going to give me a value of 60. I'm going to take half of 60. The area of this triangle is 30 units squared. Okay? I promise you guys that is way easier than trying to find the altitude of it. I'd have to use the distance formula on this base. Okay, no matter how I do it, I'm going to have to drop a line straight down that's going to be at an angle. So I can't just count. I'm going to have to find a point of intersection, so I know that ordered pair, so then I can find that length by using the distance formula. That would take you at least 10 minutes if you had everything programmed into your calculator, versus that can be done in nothing flat. Okay, so let's one more here, okay, to do this, and then this one we'll actually do out. I won't draw it out on the coordinate plane. Okay, so let's say they give you these vertices. They say you've got 1, 0, or 1, negative 1, 4, 3, and 0, 5. And you know, obviously, if you have 3 points on a coordinate plane, it's going to be a triangle, isn't it? Okay, so I go, okay, what's the area of this triangle that's formed by this? Well, I'm going to go 1/2, always 1/2 times, and I'm going to go 1, negative 1, and then I'm going to put a 1 in like a holding spot. The last column is always going to be 1s all the way down. I'm going to put a 4, 3, and then 1, and a 0, 5, and then 1. Okay, you with me so far? Okay, now because of the way I like to do it, I'm going to do this by diagonals. Okay, so I'm going to recopy the first two. So multiplying up, I get a 3. Multiplying up, I get a 0. Multiplying up, I get a 20. Okay, so there's a 23 on the top. Multiplying down, I get a 0. Multiplying down, I get a 5. Multiplying down, I get a negative 4. So on the bottom, I've got a 1. 22 or 23 minus 1 gives me a determinant of 22. What's half of 22? 11. That's the area of this triangle. Okay? All right. A lot of new stuff. All right, I'm going to put your homework up here. Okay, we did 2 sections. We did the multiplication section. Now, I'm going to ask you